Okay, on number 5, they give us a table that shows the mean and the standard deviation for these different turkeys and geese. And they want us to find the mean weight of all 27 birds. Alright, so basically all we're going to do is remember that we'll find the average. We need the total and divide by the number of things. Well, in this case, if I take 9 times 7.1 and add to that 18 times 5.2, that'll give me the total amount of pounds, and then all I got to do is divide it by the number of birds, or 27, and that'll give me an average of about 5.83. And that's all they need to know. So in the second one, this one's a little cryptic. They want us to use the weights of individual turkeys, and they want us to call it a x sub t, and the geese x sub g. And then we're going to find the x squares. So we need to find the standard deviation of all 27 birds. All right, so here's how this is going to work. Let's think more about the variance, because remember, all the standard deviation is the square root of the variance. And the formula for the variance is if I take all the x squares and divide them by the number of things, and then subtract the mean squared, I have the variance. Now in this case, I'm just doing the x squares for the turkeys. Now I know the standard deviation, so if I square it, that's going to be the variance. I'm trying to find the x squares. I know that there are 9 turkeys, and I know what the average of all the turkeys is 7.1. So all I've got to do now is get the sum of the x sub t squares by themselves. Add 50, divide or multiply both sides by 9, and then I get 472.6125. Now I'm going to do this again with the geese. So once again, I'm going to start off with the standard deviation, which is 0.96, but I'm going to square it, and then it's going to make it equal to all the geese added together squared, divided by the number of geese, which is 18, and I'm going to subtract the mean squared, which is 5.2. And then all I got to do again is get the sum of the x squares by themselves. So I'm going to add and then multiply by 18, and I get this. Now, I've got the x squares of the geese and I got the x squares of the turkeys. If I add those together and then divide by the total number of birds, I'm going to have a total x squared. So in this case, I'm going to take the 472 blah, 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 and add it to the 503 blah, 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 and divide it by the total number of birds, which is 27. And then I'm going to take away the average of all the birds, which they made us figure out first, 5.8333. Make sure you use the not rounded version, and then square it, and that'll give me the variance. And once I have the variance, which is 2.17, all I've got to do is square root that, and that'll give me the standard deviation for all the birds. All right, so let's take a look at number 6. In number 6, it says that in a certain country, 68% of the households have a printer. Find the probability that a random sample of 8 households, 5, 6, or 7 of them have a printer. Now, when they have a sample, I mean, really, we're only really using that a lot of times when it's a binomial distribution. That would definitely be something to look at. So is it a yes or no kind of situation? Yeah, it's whether they have a printer or don't. We know the probability of success. It's 68%. So all I got to do now is put the probability of failure, which is 1 minus 0.68 or 0.32. And if I'm going to find the probability of a binomial distribution, well, first I have to find them for each individual one. I'm going to use the combinations, 8 combination 5, and then the probability of success times 5, and the probability of failure times 8 minus 5. And then I'm going to repeat that for the 6, 8 combination 6, and then I'm going to repeat that for the 7, and then I'm going to find these 3 probabilities, and then I add them together to get the total probability of 5, 6, or 7. And when you do that, you'll end up with about 0.722. All right, now in number 2, you'll see they say use a approximation to find the probability. All right, so when you're talking about a binomial distribution and they want us to use a reasonable approximation, we're almost certainly talking about changing it to a normal distribution and approximating it, finding the probability using a normal distribution or the tables. So anyway, in this case, I got 500 is my sample size, and if I take the probability that's greater than 337, all right, well, first the binomial, the parameters are 5, 8. If I multiply the 500 times the 0.68, that'll give me the mean, or the expected value. And then if I multiply the mean, or the expected value, times a failure, or Q, I'll get the variance, which is 108.8. Now, I've got all the information I need. All I've got to do is standardize this, but keep in mind that when I'm making an approximation, I've got to use a continuity correction. And so in this case, it's always going to be a half above or half below. In this case, I want to know the probability that x is greater than 337, but it can't include the 337. So that means that I'm going to use, instead of 337, I'm going to use 337.5 as my number. And then I'm going to use the standard, the z-score formula. I'm going to take away 340, and I'm going to divide by the standard deviation, which is going to be the square root of 108.8. And that's going to give me my z-score. And when I do that, I'll find out that my z-score is negative 0.2396. I probably can round that to 0.3 or 0.24. Anyway, when you go to the table, we realize there's no negative values, and what we've got is we've got this negative 0.24, and we want to find the probability of everything greater than that. Well, we can't using the tables, but what we can do is find a symmetrical brother, 2.4, and find everything less than that. The probability will be the same, and that probability is on the table. So I'm looking for 2.4, and it's going to be less than that, and so I find it's going to be about 0.595. And then the last thing is justify it. Well, keep in mind, I only can use this approximation if n times p is greater than 5 and n times q is greater than 5. In this case, it is 500 times 0.68 is greater than 5, and 500 times 0.332 is also greater than 5. So that's all you really got to say. That's all they're looking for. All right, now number 7. Find how many different ways we can arrange the 9 digits into numbers if there's no restrictions. All right, different arrangements, different numbers that mean the same thing. All right, so let's find out how many ways we're going to do that. Keep in mind, we're talking about permutations, but when we're arranging everything, then we just got to do factorial. So in this case, we've got 9 digits. And so that's going to be 9 factorial. But then remember, if there's anything that's identical, we've got to divide by that. So there's 2 2s, and there's 2 7s, and there's 3 8s. So we divide by 2 factorial, 2 factorial, and 3 factorial. And then we get, with no restrictions, 15,120 ways. Now, in the second part, they want to know how many numbers we can make that are even. Well, if it's even, the last digit is either going to have a 2, or it's going to have a 6, or it's going to have an 8. And it's not going to vary. So the thing is, now I take that 2 out. It has to be a 2. So now I'm only wondering what happens with the other 8 digits. Well, out of those 8, 2 of them repeat and 3 of them repeat. So then I get the number of ways for that. And then if the last digit's a 6, I take that out of the mix. And then I try to figure out how the other numbers can be arranged. And again, there's now 2 7s and 3 8s and 2 2s. So then I get that number of ways. And then if the last digit's an 8, I take it out. And there's still 2 8s left over. So it's 2 2s and 2 7s and 2 8s that I have to divide by. So then I take all these ways and add them together, and I get the total number of ways that I can get even numbers. All right. Now, in the last B part, it says Sandra wishes to buy some apps for her smartphone, but she's only got enough money for 5. And there's 3 training apps and 6 social network apps and 4 games, and she wants to buy at least one of each. And so we're talking about combinations here. The key word here is she's choosing them. And so if I've got 3 training ones and 6 social ones and 14, but I need to have 1 of each. Well, the question is, how can I pick 1 out of the 3 and 1 out of the 6? And I just got to look at all these different variations. So in the first go round, if I only pick 1 training one and 1 social, well, then I'm going to have to pick 3 of the games. And then if I switch that up and I do 1 training and 1 social, well, now I only can do 2 of the games. And see, now I can just kind of work it around. Okay, so 1 training and 3 social. Well, now there only can be 1 left of the games. So then I go, okay, well, what if I got 2 training? Well, now I could get 1 social and 2 games. And if I get 2 training, I could get 2 social and 1 game. And that's all I can do with that. So now what if there's 3 training? Well, now 1 social and 1 game. And then I take all those ways and add them up, and I get a total number of ways. And that would be the answer. Now, rounding 3 significant figures would actually be 138,000, or I'm sorry, 13,800, because the first 3 figures, 138, are the 3 significant figures. And so this I would show you that too. All right, hope that helped. Thanks for watching.